Hi everyone, welcome back to my AP Calculus class. Today I'll keep explaining some problem, application problem with definite integration, which is solid of revolution. Last time I explained the general solid volume, right? And today I'm gonna find volume of solid of revolution. Suppose there is a y equals fx graph here. This is a y equals fx graph. And then I wanna find volume of solid formed by revolution about the x-axis. So this is this shape. Okay, this shape is revolved around the x-axis, and then you're gonna find these kind of shapes, right? This kind of solid, right? So how can you find that solid volume? It is exactly the same concept, just to find the cross-section's area and then integral a to b cross-section's area dx. So this is, that cross-section shape is always a circle in this case, right? It looks like a disc, so we call that disc method. Because some area is revolved about x-axis, or sometimes revolved about around the y-axis. Anyway, some area revolved about the axis, that cross-section, usually that cross-section shape is a circle, right? Looks like a disc. So just to find that circle's area. So if this center of a circle, that point x value is x, and then the radius is what? Y value of that function. If that function graph is y equals fx, y value of that function, that is radius of that disc. So what is AX? Area of that circle is pi r square, pi times y square. And y equals fx, right? So this is pi times fx squared. Because we have to find that a of x, because it cut this solid perpendicular plane to x-axis. That's why we're going to find that a of x. And then integral of that circle's area, pi r square, pi y square, pi fx square dx from a to b. Okay, this is a, this is b. That is volume. We call this a disc method. I solved one example problem about the disc method, and then I'll keep going to keep explaining to Washer's method. Okay, let's go to example of a disc method. What about example 7? Find the volume of solid generated when the region bounded by y equals x square, x equals 2, y equals 0 is rotated about the line x equals 2. So this function is, I think this function, so y equals x squared, x equals 2, this line is x equals 2, y equals 0, that means x-axis, right? The equation of x-axis is y equals 0. So this is y equals 0. So this is shaded region, right? This region bounded by these three equations is rotated about x equals 2. So x equals 2 is this line. Rotate around this line. So what kind of shape we can make it? Maybe looks like this, right? Now if we cut the middle perpendicular to y-axis, that cross-section's area, this area is circle, right? It is AY, because we cut this solid perpendicular to y-axis, find that cross-section's area in terms of y. Okay, the center is x equals 2, and then if that is y, this length is x, and then this length is what? That's 2, because this line x equals 2. So radius of that cross-section circle is 2 minus x, right? Okay, this part, the radius, that is 2 minus x. So pi 2 minus x squared. That's that cross-section's area, right? But we have to find that area in terms of y. And the y equals x squared, right? So what is x equals? Square root of y. So I'm going to substitute square root of y for x. And then that a of y is equal to pi times 2 minus root y whole things squared. So volume is integral a to b, those two values be y values. So y is 0 to 4. That is 0 to 4. Integral 0 to 4 pi 2 minus radical y whole thing squared dy. This is the equation to find the answers, right? So that is equal to pi is just coefficient, and then this part 2 minus root y whole thing squared is a squared minus 2ab plus b squared form. So 4 minus 4 root y plus y. So integral 0 to 4 minus 4 root y plus y. So pi times 4y, integral of 4 is 4y, and then what is integral of negative 4 root y? This integral is negative 4 times y to the 1/2 powers, so 1 over n plus 1 times y to the n plus 1 powers, so it's negative 4 times, this is 2/3 y to the 3 over 2 powers. Negative 8 over 3 y to the 3 over 2 powers plus y. Y's integral is 1/2 y squared from 0 to 4. Plug in 4, and then plug in 0. So if you plug in 0, everything is 0. So just plug in 4. Pi times 4 times 4 is 16 minus 8 over 3 times 3 over 2, and the y is 4. 4 to the 3 over 2 powers, right? So 4 is 2 squared, so it is 8 plus 8. Okay, so if you calculate that, it is 8 pi over 3. This is the final answer. Okay, so basic concept is not different, right? Just to find the cross-section's area. If that cross-section is perpendicular to y-axis, find the ay. If you cut the solid perpendicular to x-axis, find the ax. And the integral from lower limit to upper limit, ax or ay, dx or dy. That's the volume one. We call this a disk method. That cross-section is always a circle. Okay, next part, it is Washer's method. We call that Washer's method. If there are two function graph, y equals fx and y equals gx, then these two functions boundary region is this. If the boundary region is rotated around x-axis, okay, you're gonna make some these kind of shapes, I think. Circle. Something like this, right? That area, the boundary region by those two function graph is rotated around x-axis, kind of shape, kind of empty inside. This kind of jar shapes inside, right? If you cut perpendicular to the x-axis, the cross-section shape is not circle, that is donut shapes. Looks like this, right? Looks like washers. So we call that Washer's method. What is cross-section's area? Bigger circle's area minus smaller circle's area. Because bigger circle's radius is r, smaller circle's radius is small r. That means pi large r square minus pi small r square. That is cross-section's area. Okay, that large r usually y value of the outer function. The small r is radius, the y value of the inside the function. Okay, just integral a to b this cross-section's area dx. That will be volume. Okay, so anyway, same concept. Find that cross-section's area, but cross-section shape is donut shape. In this case, we call that Washer's method. Okay, I want to solve one example problem, example 8. And then today's lecture gonna be done. Find the volume obtained when the region bounded y equals x squared and y equals 2x is revolved about the x-axis. There are two graphs here. This parabola is y equals x squared. This straight line is y equals 2x. Boundary region means this, right? This shades the region. It is rotated about the x-axis. So what kind of shape are you gonna find? I'm gonna draw it. Maybe something like this, right? If the boundary region rotated about x-axis, this kind of shape, right? If we cut the middle, the perpendicular to x-axis, the cross sections will be donut shape, right? The bigger circles area minus smaller circles area. So we have to find that green color regions area looks like this. Okay, so how can you find that area? Bigger circles area first, right? Pi large r square minus smaller circles area pi small r square. Large r is the large r is y value of that outer function, which means y equals 2x in this case. So pi times 2x squared minus smaller circles radius is y value of the parabola, right? X squares, right? So pi, y squared of this parabola. So x squared squared. X squared squared. This is the area of that shaded region, cross section. So integral from lower limit of x 0 to upper limit of x 2 0 to 2, because x squared and 2x they have intersection points at 0 and 2. Factor this, x minus 2 equals 0, right? So x equals 0 or x equals 2. So 0 to 2, pi is coefficient, then 2x squared is 4x squared minus x squared is x to the fourth power dx. So pi is still coefficient, and then 4x squared is integral 4 over 3x cubed minus integral of x to the fourth 1 over 5 f to the fifth 0 to 2. Plug into first. I'm sorry, I touched something wrong. Okay, let me quickly go back there. Oh, I'm so sorry about that. But I'll go back there very quickly. Don't worry about that. Woohoo! Yeah, I'm almost there. Yes. Okay. Quickly draw again. That is revolved about x-axis. So bigger circles area minus smaller circles area. So I'm gonna find that donut shapes area, right? So integral of, what was that? pi is outside, and then bigger circle's area is pi r squared, y is 2x, so 4x squared, minus smaller circle's area pi y squared, y is x squared, so x squared x to the fourth powers dx 0 to 2, so pi 4 over 3x cubed minus 1 over 5x to the fifth 0 to 2, plug into 4x 4 over 3 8 minus 1 over 5 32 minus 0, so 32 over 3 minus 32 over 5 pi. So it is 15 over 160 minus, 160 over 15 minus 96 over 15 pi, which is 64 pi over 15. This is the volume. Okay, I explained disk method and washers method. Basic concept is the same, just find that cross-section area. For the disk method, cross-section shape is circle, so you just pi r squared, that r is y usually. If that revolved about the x-axis, the radius is y, so pi y squared. Find that ax, that means cross-section area in terms of x, and the integral a to b ax dx, that is going to be volume. What about washers? Washers cross method, cross sections shape is donut shape, so bigger circles area minus smaller circles area. Okay, and then integral a to b ax dx, still they're gonna be volume. I quickly explain two methods and then quickly solve two example problems. The next time I keep explaining application problem with some problems. Okay, next video. Thank you so much for watching my video, and click subscribe and like and turn on the notification. Okay, see you. Bye bye.